The northern lights, also called aurora borealis, can be described as beautiful displays of lights dancing in the sky. In this video, we will be discussing how and why auroras form, where they occur, and what each color represents. To begin, the term aurora means dawn in Latin and is the name of the Roman goddess of the morning. Borealis comes from the root boreas, which is the name of the Greek god of the north wind. Thus, the term aurora borealis is formed. In addition, the Earth also has the southern lights, or aurora australis, where australis is Latin for southern. The southern lights are talked about less, however, they are made from the same processes as the northern lights, just on the southern hemisphere.
Auroras are usually seen as bands or rays of light that spread out across the horizon and look as if they are extending into space. Auroras can come in various shapes, for example, a rayed arc, dual bands, or coronas. Scientists are still unsure of how the shapes come to be, or as a geologist would say, they are not well understood. According to NASA, auroras usually occur in ring-shaped areas about 4,000 kilometers in diameter around the magnetic poles of the Earth. These rings are known as auroral ovals. In the northern hemisphere, the aurora is mainly seen around far northern latitudes in places such as Alaska, Greenland, northern Scandinavia, and Russia. They can also be seen as far south as Mexico, around 35 degrees latitude, although rare. In the southern hemisphere, the aurora is mainly seen around the edges of Antarctica, but occasionally it can reach places like New Zealand, Chile, and Australia.
So how does this phenomenon occur? To begin, the sun emits energy into space, called the solar wind. The solar wind consists of electrically charged particles such as protons and neutrons. As the particles travel through our solar system, they eventually hit Earth's magnetic field. When they interact with the magnetic field, most of them are deflected, creating a huge shield-like vicinity called the magnetosphere. The magnetosphere stretches about 60,000 kilometers towards the sun and several 100,000 kilometers away from the sun on the tail end. Some of these electrically charged particles leak into the magnetosphere and are converted into electric currents and electromagnetic energy. They are stored in the magnetosphere, mainly the tail, and then are guided by the magnetic field into the atmosphere where they produce the aurora around the poles. Really strong auroras are caused by solar flares or coronal mass ejections, which emit enormous amounts of energy into space. What is happening when it reaches the atmosphere? The lights we see are the result of the collisions between the electrical currents and gases within the atmosphere. Here we are witnessing masses of electrons from the magnetosphere transfer their energy to the gases in the Earth's upper atmosphere, nitrogen and oxygen. As the electrons transfer their energy to oxygen and nitrogen molecules through collisions, they make the gases move to an excited or higher energy state. As the gases return to their normal state, they emit photons, or small bursts of energy in the form of light. Because of the massive amounts of electrons bombarding the atmosphere, the nitrogen and oxygen create enough light emissions for human eyes to detect, allowing us to see these beautiful auroras.
Why do the auroras have different colors? The variations in color depend on which gas is being excited and how excited it becomes. The color also depends upon how fast the electrons are moving or how much energy they have at the time of their collisions. Oxygen can emit green light from colliding with high-energy electrons and red light with low-energy electrons. Nitrogen usually gives off a blue light. When these colors blend, it can lead to purples, pinks, and whites. Do other planets have auroras? Auroras have been observed on Uranus, Saturn, Mars, and Jupiter. Even some of Jupiter's moons have been observed with auroras, like Europa and Ganymede.
When is the best time to see the auroras? The best time to see auroras is at high latitudes at night, preferably in the winter when it is darker for longer and there is no light pollution. In winter, there are clear skies, less haze, and less water vapor in the air.
Why are auroras important? Because auroras are produced by constantly changing strong electrical currents, they interfere with various systems such as telegraphs, radios, and telephones. Auroras can cause problems like disruptions in communications and power outages. Additionally, they can bend and absorb radio signals or interfere with satellite communications. Not only have they been studied in modern times, but they have also been important throughout history. For some cultures that lived at high altitudes, auroras became rooted in their religion, with various beliefs about what they meant. Some believe they were the dance of animal spirits, and others believe they enhanced the fertility of the earth. There were also beliefs that they were souls at play, great dragons or serpents in the sky, or a bridge by which the gods traveled from heaven to earth. In lower altitudes, some cultures thought them to be bad omen, of trying times or severe weather to come. Nevertheless, many cultures had great respect for these magical displays.
Some people also wrote about what they saw. One man named Robert Service wrote about them in the Ballad of the Northern Lights, published in 1908. He wrote, "And the skies of the night were alive with light, with a throbbing, thrilling flame. Amber and rose and violet, opal and gold it came. It swept the sky like a giant scythe, it quivered back to a wedge. Argently bright it cleft the night with a wavy golden edge. Pennants of silver waved and streamed, lazy banners unfurled. Sudden splendors of sabers gleamed, lightning javelins were hurled. There in awe we crouched and saw with our wild uplifted eyes, charge and retire the hosts of fire in the battlefield of skies." Hopefully, the auroras will continue to perform their beautiful and mystical arrays for millions of years to come.